In this last section of 4.1, we're going to talk about angle of elevation and angle of depression. Angle of elevation is an angle formed by a horizontal line and an observer line of sight to an object above. So basically the object that is above the observer. Angle of depression is an angle formed by a horizontal line and an observer's line of sight to an object below. So basically the object that is below the observer. So what we're going to do is going to be doing an example of angle of elevation and angle of depression using what we did in trig function, trig ratio, finding missing side length, and finding missing angle. So for our first example, we have a word problem. So in this word problem, we have to make sure we identify key information in order to create our picture to have a better visual, and then use the picture and the information from the word problem to help us find the angle, the missing angle or the missing side. So our word problem is a group of hikers climbs to the top of a 1,500-foot mountain. When the hikers looks down at an angle of depression of 37.1 degrees, they can see their campsite M. What is the horizontal distance between the campsite and the hikers? So, what we should know is that the group of hikers climbs to the top, top of a 1,500-foot mountain. When the hiker looks down at an angle of depression, so I'm just going to write or underline depression, of 37.1 degrees, they can see their campsite M. What is the horizontal distance between the campsite and the hikers? Now, we're going to use the 1,500-foot mountain to better illustrate our triangle. So, first off, we're going to draw a picture. It doesn't have to be to scale. So it's going to be a right triangle. Now here, well, first, I'm going to use the 1,500-foot mountain. So basically, that's where 1,500 is. So I'm going to write it sideways because I'm on limited of space. So 1,500. Now, basically, the hikers are here. When they look down at the angle of depression, this is where it's going to get a little bit confusing. So angle of depression basically means starting from the horizontal line here that is parallel to the horizontal at the ground. So basically my angle of depression is right here. So 37.1 degrees. So this is where your angle of depression is. So angle of depression. So angle of depression is 37.1 degrees. So looking down, they see their campsite M. So I list out my information. The height of the mountain is 1,500 or 1,500. When the hikers look down at an angle of depression, so basically the horizontal line parallel to the horizontal ground, the angle of depression from that horizontal line to the slanted line is 37.1 degrees. So when they're looking at their campsite M. Now the question is, what is the horizontal distance between the campsite and the hikers? So what I mean by the campsite is basically, here's a campsite, here's a hiker, but they're asking for the horizontal distance. So basically the horizontal line or the horizontal ground. So this is going to be our X, our unknown. So now we have a better visual. What we're going to do is now we need to find the information using angle of depression, using 1500, using X. So first thing first, angle of depression, we can use the angle here or here. Now, what we can do is, if we were to use geometry, there's two ways. If we were to use this angle here, we can use the complementary angle. So what I mean by complementary is that if you look at this horizontal line is parallel to the horizontal ground, and it's a right angle with the height of the mountain. So if it's a right angle here, and if these two lines are parallel, then this two angles will add up to 90. What you can do is you can use complementary angle. So that means these two angles should add up to 90. So if I want to find this angle, I can do 90 minus 37.1, which will equal to 52.9 degrees. So this is 52.9 degrees. Or instead of that, I can use from geometry, again this is also from geometry, complementary angles. I can use the angles, the interior alternating angles. So basically, if these two lines are parallel and this is a transverse line, so we can use the definition of interior alternating angles. So if this is 37.1 degrees, then over here is also 37.1 degrees. Let me write a different color to make it darker. So again, we got 52.9 using the definition of complementary angles. So 90 minus 37.1 degrees equals 52.9 degrees. Or you can use alternate interior angles. So since that's 37.1, we can declare this one 37.1 degrees. And if I want to check, 52.9 plus 37.1 will equal to 90. So, to test that out, since I'm working with decimal, but you could do this by hand. So if I use 37.1 plus 52.9, it will add up to exactly 90. And since these two angles add up to 90, plus 90, for the triangle, it will add up to 180. So these two measurements are correct. So we can use any angles. Now, if I want to use the 52.9 degrees, then from that angle, so say if I want to use 52.9, which is our angle, and what's adjacent to it, next to it, not the hypotenuse, is the 1500. So that's our adjacent. What's opposite is x. So the trig function that you use only adjacent and opposite is tangent. So I'm going to write here tan of 52.9 degrees equal, now tan is opposite over adjacent, so I will put x on the top since that's opposite, and I put the adjacent, which is 1,500. Now if I want to get x by itself, what I'm going to do is going to multiply both sides by 1,500, and when I do that, it's going to look like this: 1,500 times tangent of 52.9 degrees equal to x. I'm going to move a little bit up. So x, we're going to find the value of x. So I'm going to type this in to the calculator. So going to calculate. And of course, always check when you're in degree mode since we're working in degrees. So I'm going to put 1,500 or 1,500. Hit trig, go to tangent. Then type in our angle, so 52.9. Hit Control Enter. I get 1,983.36. So I'm going to write that down. So x is approximately 1,983. Alright. Now, that's when I use 52.9 and using the tan function. So say instead of using that, I decided to use 37.1. So my angle is 37.1, and what's adjacent to it is x, so I'll put adjacent, which is x, and I put what's opposite is the 1,500. Okay, so again, the only trig function that would use adjacent and opposite is tangent, or we could use cotangent. But let's stick with tangent to stick with the basic. So it's tan of 37.1 degrees equal, my opposite is on the numerator, so 1,500, and my denominator is the adjacent, so it's x. And then if I were to just get x by itself, I'm just going to switch these two sides. So x equal 1,500 divided by tan of 37.1 degrees. Alright, so let's type that in the calculator. So I'm going to put 1,500 divide, I'm going to put parentheses since I'm working with a function, hit trig, go to tan, put 37.1, get outside a parenthesis, hit Control, Enter, I get 1,983.36. pretty much the same as the one before. So let me write that out. So x, oops, no, not that color. X is approximately 1,983, and I just only rounded to the whole numbers. So the blue one, I used 52.9 degrees, and I still end up using the tan function, but it looked different, and I got 1,983. The purple one, I used 37.1 for the angle, and I still use the tangent function, but it looks different from what we did before. So if we go back, so the 52.9 degrees, this is what the function looked like when x is by itself. So x equals 1500 times tangent of 52.9. Now when I use the 37.1, x was equal to 1500 divided by tan of 37.1. And as you can see, both x values are the same. So there were two ways to solve this, but they both use tangent function. So again, there were two ways, meaning two different angles, even though they use tangent function. But there's two more ways. You could have used cotangent, and you still end up the same answer. So regardless what method you use, as long as you use it correctly, you set up correctly, you match up your information correctly, you should get the correct answer, and regardless of what method, it's going to be the same. Alright, so from our second example, the question is, from point P on the ground, the angle of elevation of an airplane is 23 degrees. The altitude of the plane is 1,200 meters. What is the distance from point P to the plane to the nearest tenth of a meter? So, important information that we should know. Point P is on the ground. The angle of elevation of the airplane is 23 degrees. The altitude of the plane is 1,200 meters. What is the distance from point P to the airplane to the nearest tenth of a meter? So, using the information I highlighted, so from point P on the ground, so point P, that's our from the ground. So now, if it's on the ground, here's our horizontal ground. So at the angle of elevation, so that means it's going to be above the ground. So looking up to the airplane, the angle of elevation, which is right here, angle of elevation is 23 degrees. The altitude, meaning the height from the ground to the airplane, is 1,200 or 1,200. This is the altitude. So I'm going to write altitude right here. Altitude. What is the distance from point P to the airplane? So basically, this is x, the slanted line, so from point P to the airplane. And make sure our answer is to the nearest tenth of a meter. So, when it comes to angle of elevation, there's less steps compared to angle of depression. So that means that there's still multiple ways, but it's going to be easier. So, if we were looking for x, the distance between point P to the airplane, which is at the top, we first have to identify our given information from this picture. So, using our angle, and if I were to compare it, the 1200, the altitude, is opposite of 23 degrees because it's across. Then here, this is our hypotenuse because using the horizontal ground and the altitude is perpendicular, so this is our right angle. So since this slanted line is across from the right angle, this is our hypotenuse. So again, this is our right angle because the horizontal ground and the altitude are perpendicular to each other. So our information that we know for sure is angle is 23 degrees. What's across, our opposite, is 1,200. And then our slanted line, the distance from point P to the airplane, that's our hypotenuse, which is x. So, looking at our information that we know, the only trig function we're going to use that have opposite and a hypotenuse is sine, but we can use cosecant. So, let's use sine. So sine of 23 degrees equal, now opposite is the numerator, so 1200. And then our denominator is the hypotenuse, so x. So if we want to get x by itself, we're just going to switch these two. So x equal 1000 over sine of 23 degrees Alright, so let's solve for that one. So this is the correct setup. Now if in the event you get the value of x wrong, but your setup was correct, you still get partial points. Alright, going to calculate. Now again, make sure you're in degree mode because we're working with degrees. So here's what we're going to type in. 1200 divided by sine of 23 degrees. So go into the calculator mode. I'm going to put 1200 divide parenthesis trig sine, and then I'm going to put 23 degrees, exit out of parenthesis, control enter. So 3071.17. But it says round to the nearest tenth, so that means one decimal place. So since it's 0.17, since that 7 is above 5, I'm going to round the 1 up. So 3071.2. So my x is 3071.2 meters. Now that's using the sine function. I could use the cosecant function. Now cosecant is going to be the flip. So if I were to use cosecant, so cosecant of 23 degrees equal, so for cosecant, my numerator will be the hypotenuse, so that's x, and my denominator is the opposite, which is 1200. And then if I were to get x by itself, I would multiply both sides by 1200, and this is what's going to look like. So 1200 times cosecant of 23 degrees equal to x. And then now going to type that into the calculator and see what we're going to get. So, I'm going to type in 1200 or 1200 times cosecant, so I'm going to hit trig. I'm going to go all the way to cosecant, and I'm going to type in 23 degrees, exit out parenthesis, hit control, enter, 3071.17. Since it asks for the 10th of a meter, I'm going to round to 1 decimal place. So x equals 3071.2 meters. So looking at that, using whether it's cosecant or sine, I still get the same value for x. So using the sine function, I got this value. Using the cosecant, I got this value, which is the same. Now there should be a little note for any type of problems using trig function and finding missing sidelings, missing angle. This calculator, the TI Inspire CX CAS, now when you hit trig, it has all the 6 functions. Now, the TI 83s, 84, the scientific calculators, is going to be different. If you were to use cosecant, secant, and cotangent, you have to write it as their reciprocal function. So, if you're using cosecant, you have to write it as a 1 over sine function, because scientific TI Inspire, not TI Inspire, TI 83s and 84 only have sine, cosine, and tangent, not cosecant, not secant, not cotangent. It only has sine, cosine, and tan. So if you plan on using cosecant, you have to type it and write it as 1 over sine. If you were using secant, you have to type it or write it as 1 over cosine. If you're using cotangent, you have to type it or write it as 1 over tangent. So in best case scenario, if you're using scientific calculators, TI 83s, TI 84s, just stick with sine, cosine, and tangent. But when you're using TI Inspire, you're able to use any of the 6 functions. But scientific or 83s, 84, stick with only sine, cosine, and tangent.